Okay, so hello and welcome back. So what remains from this chapter is two more concepts from analytical geometry, or analytical geometry, you can say. And one of them, which is, of course, these are all very basic and important concepts, is the distance of a point from a line. Meaning that suppose that you have, for example, this line over here. This is the y-axis and this is the x-axis, and this goes this way, and basically this is your line. If you call this, for example, L, and your line is ax plus by plus c is equal to 0, and there is a point over here, for example, and when we say that the distance of a point from a line, whenever, not most of the time, I would say all the time, distance means perpendicular distance. So basically in geometry I have seen many cases, and whenever in the past, whenever I have seen distance, that meant perpendicular distance. So that means that the perpendicular distance of this point from this line, for example, if I assume that this line is perpendicular to the line, then this distance over here, d, is the distance of this point P from this line L. And P, for example, let's say that you have x1 comma y1, and you want to find this d. Now, in order to find this d, what you want to do is the distance of a point from a line is basically the length of the as I mentioned, the length of the perpendicular drawn from this point to the line. Now, if your line is basically this ax plus by plus c is equal to 0, and the distance of this line from this point is d. Now, if you draw this perpendicular PM, which is basically the distance of the point from the line as well, and you can see that this line has an x-intercept and it does have some y-intercept as well. So you can call, for example, this point, you can call it, for example, Q, and this point over here you can call it R. And of course you need to basically find the x in the previous section. We talked about the x-intercept and the y-intercept of a line, and we said that when you have a line in the form ax plus by plus c is equal to 0, and if basically in case c is not equal to 0, then you can write, we basically rewrote the equation of the line in the form x over negative c over a plus y over negative c over b. Negative c over b is equal to 1. And then as we compared this to x over a plus y over b is equal to 1, there we concluded that a is equal to negative c by a and b is equal to negative c by b. That means that the x-intercept of this line, whatever that is basically negative c by a. So the coordinates of this point therefore becomes negative c by a, and the y coordinate is of course 0. The coordinates of this point is basically the y-intercept, so the x-intercept is 0, and the y-intercept of this point is the y-intercept of the line, of course, which is negative c by b. Negative c by b. Of course, this b is supposed to be a capital B. Don't want to make mistakes here. This is a capital B. So that's basically about these 2 points. And these 2 points are, of course, needed in order to find the distance between the point and the line. And then what you need to do is that now we have a triangle over here. You can imagine that we have a triangle over here, this triangle, and this over here. Let me erase this. So the coordinates of this point is basically the x. Your x is equal to 0, and negative c by b is the y coordinate of this point. So now you have this triangle over here, PRQ, and in this triangle, so you know that the area of this triangle is equal to basically 1/2 times the base times the height. So this is your height and this is your base. So you can say that the area of triangle PRQ is equal to 1/2 times the base, which is RQ times PM. And basically, if I rewrite this over here, I can basically multiply the whole equation by a factor of 2. I'll get 2 times area of triangle PRQ is equal to RQ times PM. And so PM, which is basically this distance over here, PM is equal to 2 times area of triangle PRQ over RQ. So I can call this equation number 1, and that is PM. So that is basically one part. And also in the beginning of this chapter, probably I haven't talked about that here, but I mean, generally in analytical geometry, if you have basically a triangle over here, let's say you have basically some point A, for example, x1 comma y1, and you have basically this point over here, let's say B, x2 comma y2, and if you have this point C, for example, x3 comma y3. If you have these 3 points, and if they form a triangle, then the area of this triangle, and of course this is supposed to be this way, and this is your x and y axis. The area of this triangle, area of triangle ABC is equal to basically 1/2 times the absolute value of, I would basically derive this formula, but it's a lot of trouble and it's not required really anymore, but it's very easy to derive this formula. But anyway, the formula is to find the area of this triangle. You can write 1/2 times the absolute value of x1 times y2 minus y3 plus x2 times so y3 minus y1 plus x3 times y1 minus y2. It is x1 times y2 minus y3, x2 times y3 minus y1, x3 times y1 minus y2. So you see that this is like a cycle. So in this formula you have a 1/2 over here, and then this whole expression is inside an absolute value function. Then you have x1, x2, x3 plus x1 plus x2 plus x3, and basically these three, all the three of these x1, x2, x3s are multiplied by these expressions. And this expression goes from, basically it's like a cyclical cycle. You go from, basically, if you have y1 and if you have y2 here and if you have y3 here, you start at y2 and go to y3, meaning you write y2 minus y3, and then you have to move from here to here. So then you have y3 minus y1, so this is number 1, this is number 2, and then you have y1 minus y2, y1 minus y2, this is number 3. So you need to start from here, and then of course follow the numbers 3 to 1, meaning that this is the last one, this is the first one. So logically you go over here and then one step and again one step and so on and so forth. So that's your formula here. Now you do need to use this formula in order to find the area of the same triangle, because this formula gives us the area of this triangle in terms of these 3 points. And that's, of course, that's definitely what we want. Otherwise we don't want to have something like area of a triangle right in the middle of this formula. That would make no sense. So we have to somehow break it down. So I write this as, this as the area of triangle ABC, triangle PRQ, PRQ is equal to 1/2 the absolute value of, now over here I have these 3 points. So I have x1 comma y1, I have 0 comma negative c by b, and I have basically negative c by a, comma 0. And I take this as point 1, I take this as point 2, and I take this as point 3, meaning that this is x1 y1, x2 y2, x3 y3 in this formula. So now x1 is basically x1 here times y2 minus y3. So this is y2, this is y3. So you have to write negative c by b minus 0 plus x2 over here is 0. So I will not simply write it, because 0 times anything is 0. And x3 is equal to negative c by a. So I write this as negative c by a times y1 minus y2. So that's y1 minus negative c by b, which becomes y1 plus c by b. And if you simplify this, you'll get 1/2 times the absolute value of basically x1 times negative c by b, or negative c by b times x, minus c by a times y1. This is of course x1 y1, and you have negative basically c squared over ab, So this becomes basically 1/2 negative Okay, so now what I can do is that I can take a C by AB out. I can write this as so this was basically area of triangle PRQ is equal to 1/2 of this. So I can write basically 2 times area of triangle PRQ is equal to basically the absolute value of negative C by B, for example, times x1 minus C by A times y1 minus C squared by AB. Okay, and then I can take a basically I can write this as negative C by AB. I can take out over here. So I can write this as, so I can write 2 times area of triangle PRQ. PRQ is equal to the absolute value of this. Since I took it out of the absolute value, I put it back in an absolute value so that I'll have no problem if I do anything with the equation. And I multiply it by if I take a C times C over negative C, so I take this this one out and a B out, and I've taken basically an A out from the denominator. And since it's not present here, I have to add it to the numerator. So it becomes A times x1. Now if I take a negative sign out here and C out here and A out here, I've taken a B out in the denominator. Since it's not present here, I add it to the numerator, so that becomes B times y1. And over here I've taken a C negative, basically C over AB, so only a positive C remains here. Positive C remains here. And so that is basically one thing that we can use later. Now, one more thing that we can do is that we can calculate QR here, meaning that one point is this one, another point is this one. So you know that you do know the distance formula, or basically the distance between 2 points AB. If basically, for example, if A is x1 comma y1, and if B has coordinates x2 comma y2, then AB is going to be equal to the square root of x2 minus x1 whole squared plus y2 minus y1 whole squared. So now if I want to calculate what QR here is, so then QR, based on this formula, which is basically also called the distance formula, I can write it as the square root of, basically, for example, take this as 0.1 and take this as 0.2, for example, for this operation. And you have x2 minus x1 is negative C by A minus 0, whole squared. I didn't write the minus 0 because it's not really necessary, plus y2 minus y1. So 0 minus this becomes C by B whole squared, and that is equal to basically C squared by A squared plus C squared by B squared and then we can write this as, we can take, again, you can take a, over here you can take a c by ab out, you can take a c by ab out, you can take a c by ab out, and of course put that in the absolute value function, because you've taken that out of a square root function. So if c by ab goes inside, c becomes c squared, and of course a becomes c squared by a squared plus c squared by b squared, right? Now if I take a c by ab out of the square root function, so when I can write this as times, basically taking a c squared goes out, becomes c, a squared goes out, becomes a, and I've taken a b out, so I have to write a b squared over here. I have to write a b squared over here. And then over here, I've taken c out, so basically c squared goes out, becomes c, b squared goes out, becomes b. And since I've taken an a out and it's not present here, I have to add it over here, a squared. So as you can see, the distance QR is then equal to c, the absolute value of c divided by ab times the square root of a squared plus b squared. Now in the equation number 1 that we had up here, we said that PM is equal to 2 times area of triangle PQR divided by RQ. We said that basically PM is equal to 2 times area of the triangle PQR times divided by RQ. Now we have calculated 2 times area of triangle PQR is basically equal to this, so I can write this up here. I can write the absolute value of negative c over AB over times the absolute value of AX1 plus BY1 plus C over RQ, which is or QR, which is basically the same value, and that's equal to the absolute value of C over AB times the square root of a squared plus b squared. And of course you can simplify the absolute value of negative c by ab and the absolute value of c by ab. You can cancel them out, because ultimately whether you have the absolute value of negative c by ab, or if you have the absolute value of c by ab, the output of this function is going to be a positive value. So it doesn't matter whether you have a negative sign in there or not. You can cancel them out. So that means that then your PM, that means that your PM is equal to your PM, which is basically D, which is this distance over here, PM or D, the distance from this point, from this line, the perpendicular distance from this point from this line, is equal to the absolute value of AX1 plus BY1 plus C plus c over the square root of a squared plus b squared. That is basically the distance between a point and a line, the perpendicular distance of a point and a line. And the way that you use this formula is that, as we mentioned before, I will draw this over here. So suppose that you have this line over here. Let's call it, for example, this line, call it, for example, a x1 plus b y1 plus c, I'm sorry, not a y1. If the equation of this line is ax plus by plus c is equal to 0, and if you have some point over here, for example p with coordinates x1 comma y1, and the perpendicular distance of this point and this line, if we call it d, then you can use this formula to find this distance. You see that x1 and y1 are related to this point, and then ABC and A and B over here are just simply related to this line. So that's basically one of the things that we need over here. The next thing is the distance between two parallel lines that we will do in this video as well, and then we will have some exercises. Okay, so the next thing that we need, the next concept that we need here in this related to these two lines, and of course all of these, basically these concepts that we basically learn here are basically 100% required in physics. When you want to basically solve a physics problem, for example, I don't know, you want to calculate the distance between two galaxies, you want to calculate the distance between the Earth and some other star or whatever, the sun, the moon, or whatever you want to do. If you don't know how to calculate, for example, the distance, or if you don't know your trigonometry, or if you don't know your geometry, or basically all of these things, each and every one of these concepts, then over there you will get caught. So these are absolutely necessary for you to be able to do really anything in any sort of science, be it I don't know, even commerce, even biology. Even in biology you need, for example, most of the basic concepts of mathematics, statistics, and so on and so forth. So but mainly and most and foremost, you use these concepts in physics. So if you want to do a basic physics course, or if you have to do a basic physics course, you do need these concepts, and you need to learn them well. But of course they are not that complicated. These are very simple, concepts, formulas put together, and then you can use them in any way that you need. So basically now the distance between two parallel lines, the distance between two parallel lines. So suppose that, for example, you have these two lines over here. I make this a little bit longer, and I draw this line over here, and I draw this line over here, and suppose that you have these two lines which are supposed to be parallel lines. This is your x-axis, this is your y-axis. This line over here, these two lines, since they are parallel lines, they have the same slopes, so you can write their equations as y is equal to mx plus c1, for example, and y is equal to mx plus c2. meaning that they have the same slopes but they have the different y-intercepts. And therefore they are displaced along the y-axis, but otherwise they have the same slopes. So suppose that, for example, this is basically line, call this 1 and call this 2, and suppose that this is line 1, for example, this one over here, and this one is line 2. Now as you can see, this line 1 goes through the x-axis at this point. We can use this in order to basically find the distance between the 2 points, between the 2 lines. And of course, we want to find this perpendicular distance. We want to find this perpendicular distance, which is basically d, between the 2 lines. Now it's important to know the coordinates of this point, otherwise we will not be able to calculate the distance, meaning that in the previous basically concept that we derived, which was the distance from a point from a line, we said that the distance was equal to basically the absolute value a times x1 plus b times y1 plus c and this is a capital C over the square root of a squared plus b squared. So that means that basically this x1 and y1 is a point outside of this line. And in this case we have this point outside of this line, so we need the coordinates of this point, and moreover we need this line as well, meaning that we need the a, b, c and a and b again of this line over here. So we are going to use what we basically derived before in order to find the distance of this point from this line, and since this point lies on line 1, then that distance becomes the distance between the 2 lines. So now what you can do is first you need to find the coordinates of this point. The coordinates of this point are basically in the intercept form of a line. We said that if you have a lines like ax plus by plus c is equal to 0, c not equal to 0, then you can write this equation as x over negative c by a plus y over negative c by b is equal to 1, or you can write this as x by a plus y by b is equal to 1, and so your a becomes negative c by a, which is your x-intercept, which is your x-intercept, and your b becomes negative c by b, which is your y-intercept. So what that means is that your x-intercept is basically negative c by a. Your x-intercept is negative c by a. So now I'm going to use this in this situation in order to find the coordinates of this point. And of course you know that the y coordinate of this point is 0. The x coordinate of this point is negative c by a in this equation, because this equation is related to this line. So you have y is equal to mx plus c1 and so if I write this equation in general form, meaning that if I write negative mx plus y minus c1 is equal to 0, then the basically negative c by a, so this over here is a, this over here which is a 1, is b, and this over here is basically your c. Now negative c by a, and this is of course capital A, negative c by a in this situation is negative of negative c1 over a, which is negative m, So you can simplify these two negative signs and you will get negative c1 over m. So that means that the x coordinate of this point is negative c1 by m, is negative c1 by m, and the y coordinate of this point is 0. So now we have the x coordinates, we have the coordinates of this point, and we have basically the equation of this line. So I can substitute everything in this equation and get the distance of the two lines. And so based on this formula, then you can say that d is equal to basically the absolute value of a times x1 plus b times y1 plus c. And now I do need the equation of the line 2 over here, which is basically y is equal to mx plus c2, and I need to write it in general form because these a, b, and c's that you see over here, they are in general, they refer to the general form of the line. You cannot write it like this. And for example, suppose that I know that the coefficient of x is a. Now that I have written my line in this configuration, I cannot conclude that, for example, my a is equal to m. That is wrong, because if I want to write this line in general form, I would write it in the form basically negative mx plus y plus c2 is equal to 0. And then once I do that, basically you see that my a becomes negative m. Okay, so you need to be careful about that. So you basically in this line right now, as it's been written in general form, now you know that your a is equal to negative m, your b is equal to 1, and your c is equal to c2. Your c is equal to c2. So I write this as a times, which is negative m, times x1, which is negative c1 by m, negative c1 by m, plus b times, and b is equal to 1, times y1, which is equal to 0, which is, I don't have to write that, and c here over here is equal to c2. And over here I can write a squared plus b squared, which is negative m whole squared plus 1 squared, and 1 I got from here. So this is equal to, basically you can simplify these two, and simplify these two, you will get I think I made a mistake here. The line was basically the line was basically this one. So y is equal to mx plus C2. So I can write negative mx plus y minus C2 is equal to 0. This is wrong. I'm sorry. This has to be this one. And so your C becomes negative C2. And so therefore over here you will have minus C2. Minus C2. So over here now I have C1 minus C2, and the absolute value of that over the square root of m squared plus 1, which is equal to 1 plus m squared. And that is the distance between the two lines. And as you can see, basically C1 and C2 are coming from the two lines. C1 and C2 are coming from the two lines, and basically m is common between the two lines because they have the same basically slopes. And so that's basically the equation. That's basically the equation over here. Now there is only one thing, C1 minus C2 over 1 plus the square root of 1 plus m squared. So there is only one thing that we have over here, and that is basically if the equation of the lines had been given in the form, if the equation of these lines had been given in the form ax plus by plus c is equal to 0, in that case of course we would not have m squared. M squared would not be present here. So in that case we could basically go through the same process, and we would get a formula which would be basically d is equal to the absolute value of c1 minus c2 over, instead of the square root of 1 plus m squared, you would have basically a squared plus b squared. That would be the equation, that the formula that you would use in order to find the distance between the 2 points. And you can of course derive this formula using the same procedure that we went through in order to basically derive this formula. Okay. So now we have a couple of examples here, only 2 examples over here. So let's do that as well, and then we will get to the exercises. We need to be a little bit faster here because there is a whole lot of material still to cover here, and we need to get moving really. So example number 18, that's just an example. You want to find the distance of this point 3, negative 5 from this line 3x minus 4y minus 26 is equal to 0. You want to find the distance of this point from this line. So basically what we said was that when you want to find the distance of a point from a line, that would be equal to ax1 plus by1 plus c over a squared plus b squared. So d is equal to the absolute value of ax1 plus by1 plus c over the square root of a squared plus b squared. So now, in case you did not understand how we derived this formula, you might actually make some logical mistakes, or you might actually substitute your numbers wrong in this equation. The good thing about understanding the the process and the derivation and everything of all the formulas that we use is that once you understand the process by which you derive a formula, then you will be able to use it properly. And of course, whenever you forget that formula, you will be able to derive it yourself. So now over here, my a over here is equal to to 3, b is equal to -4, and my c is equal to -26. And this is x1 and y1 over here. So if you substitute these values in this formula, you will get the distance of the point from this line. So d is equal to basically the absolute value of a times, which is equal to 3 times x1, 3 times 3, plus basically plus b is -4 times y1, which is equal to -5, plus c, which is equal to -26, over the square root of a squared plus b squared. So that's 9 plus 16, which is equal to the absolute value of 9 plus 20 minus 26 over basically the square root of 25 is equal to 5. So that's 29 minus 26, that's equal to 3. 29 minus 26 is equal to 3 over 5. 3/5 units is the distance between the point and the line. And then if you, as another example, you want to find the distance between the parallel lines, find the distance between parallel lines 3x minus 4y plus 7 is equal to 0, and 3x minus 4y plus 5 is equal to 0. So as you can see over here, the equations are actually in the form ax plus by plus c is equal to 0. So what I need is basically the formula that we had here. The absolute value of c1 minus c2 over the square root of a squared plus b squared. So I have d is equal to the absolute value of c1 minus c2 over the square root of a squared plus b squared. Of course, you can basically, for example, rewrite this equation as, for example, you can rewrite it as 3x minus 4y plus 7 is equal to 0, and then, for example, write this as negative 4y is equal to negative 3x minus 7, negative 3x minus 7, and then 4y is equal to 3x plus 7, and then divide by 4y is equal to 3/4 x plus 7/4, and so over here your m would be equal to 3/4, and then you could take this and use it in this formula. D is equal to the absolute value of c1 minus c2 over the square root of 1 plus m squared, and this is basically m over here. If you did this, then you would use this formula, but there is no need to do that. So basically d is equal to this. So now you can basically write your d as basically c1 minus c2. So you can take this as C1 and C2, which is basically the absolute value of 7 minus 5, and over the square root of a squared plus b squared. So your a is 3, which is 3 squared is equal to 9, and b squared is equal to negative 4 squared, which is equal to 16. So that's equal to basically 7 minus 5 is equal to 2 over 5. 2/5 units is the distance between the two parallel lines. And that concludes this part. The next thing that we have is basically 18 exercises. We will go through them as well, because believe it or not, you do need to solve many problems in order to grasp these ideas and to basically learn the formulas and get familiar with them and so on and so forth. So next we will do 18 exercises, and then this chapter is nearly over. So I'll see you in the next video. Thank you.